Welcome everyone to the Tulsa.net user group. Tonight, Rob Richardson, a Microsoft MVP, going to talk about .NET Aspire, your DevOps companion. Rob, thank you so much for being here tonight and giving this talk. I'm going to hand it over to you.
Sounds great. I'm really excited we get to talk about OpenTelemetry today. We'll get to see .NET Aspire and how it plays really well with OpenTelemetry, the kind of built-in ubiquitous logging, tracing, and metric solution. So this is really cool. Here's the part where I tell you I am definitely going to post the slides on my site tonight, but they're already there. Let's head over to robrich.org, robrich.org. We'll click on presentations up here at the top, and here's .NET Aspire. You can get to both the slides and the code that is up on GitHub. It is up there right now. So head to robrich.org, click on presentations, and you can get to the slides and the GitHub right now. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Microsoft MVP and MCT, Docker captain, and I'm also part of some other really cool programs. I got to write this really cool book, Pro Microservices in .NET 6 with some friends, of which Sean is one of them, and that's really cool. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp, or if you'd like a Give Camp here in Tulsa, or wherever you're connecting from, hit me up on any of the socials or find me here at the after party, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I got to work on the Gulp project in version 2 and version 3. The Docker Tip of the Captain's Hat Award, that was really fun. One of my biggest claims to fame is I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. .NET Rocks mug. No, I'm just kidding. Richard Campbell's awesome. So let's dig into .NET Aspire. I've got this solution pulled up, and it's not the default. I have some extra stuff in it, but let's fire it up and see what we've got here. And the cool part is we'll actually launch lots of projects at the same time. I just push play on one project, and it launches the .NET Aspire dashboard. In a second, because I've got Zoom and Visual Studio and a whole bunch of stuff, we can see that we're logging into the .NET Aspire dashboard, much like we would with Jupyter Notebooks. And up pops the .NET Aspire dashboard. Now, if you're familiar with Project Tie, this will look really, really familiar, where we have each of the different things that we've got ready to go. Oh, looks like Redis failed to start. We may get to restart this demo in a second. Now, I do have a front-end website here that is, yep, let's start this again. It's going to spin up .NET projects. It'll spin up containers. It can spin up command line things. It will spin up other technology things. And all of that happens together in one project as I start it up. So let's get the Redis container going too. And there it goes. Cool. So now it's going to enumerate all of the services that I have running as part of this project. We see we have a web front end, an API service, Postgres database. We have some Postgres admin tool. We have a cache. This is using Redis. And a container. We also have a Redis admin tool. So let's start up the front end website. So here's that front end website, and we can see that we've got weather forecast. We've seen this before. In this case, it caches on the client for 1 second and caches on the server for 3 seconds. So if I refresh this, we can see it doesn't change, but then after 3 seconds, we'll see that it does change. Cool. We've also got weather stations, which is actually querying into Postgres. And so we'll see this calling into the back end and loading up that data out of Postgres and showing that data in the results panel. There we go. And so what we see then is a really interesting mechanism of connecting from front end to back end to database. We've also got some caching, and we've got this interesting dashboard that allows us then to view each of those, launch them really quickly, we can also take a look at the configuration associated with each one. So here's the environment variables that I have set. Let me show them. And so now we can see ASP.NET Core URLs that got injected. We've got some connection strings there for the cache. We've got some other OpenTelemetry things, and we can view them for each of the projects that we have. We can also flip over here and take a look at the console logs. Let's take a look at the front end console logs, and we can see, yep, that looks pretty much as we'd expect. The back end console logs. We can also take a look at, for example, the console logs for the Vue app. We haven't popped open the Vue app yet. We can also take a look at the console app logs for the Redis app. We do have structured logs that will give us a little bit more context around each of those log details. And so to the depth that we can infer them, then we have some really great logs there. We've also got traces, which is really, really fun. We can see that the web front end called into the API service. So if we pop open this trace, here's the web front end. It failed on this GET request. It called into the API service, and that did a database query, but then it tried again, and that database query succeeded. And so we can see the timings of each of these, and we can also pop open particular details for that as well. So let's pop open our Vue app as well, and we'll see that the Vue app is really similar to the front-end Razor app, except for it doesn't cache the client for 5 seconds. And we can refresh the database call as well. So if we come back in here and take a look at our traces, we can now see that the Vue app is doing really similar things, connecting off to that API service, going to query the database, and we can see that the timings of how those go between the services. So that was really cool. That's kind of a really elegant walkthrough of .NET Aspire and OpenTelemetry. Any thoughts or concerns? Any questions so far? Cool. So what is that? What is this OpenTelemetry thing? What is this .NET Aspire thing? .NET Aspire is an opinionated framework for development and deployment of web applications. And the cool part is not just .NET applications. We saw Vue in here. We'll see Python in a minute. It brings together all of the best open source standards and practices into that opinionated framework that makes a really cool way to deploy it. So the question that it answers here is, how do you build a cloud-native suite of microservices that's observable and easy to deploy? Now in .NET, we have lots of different things that may do, but combining them together into one package can get to be kind of intense. And that's where .NET Aspire nicely paves the path into the best practices of cloud-native applications that have lots of different microservices and dependencies. So there's that well-paved path. So .NET Aspire, we start all the microservices together with a single project. We have sensible defaults that help us fall into the pit of success. We have OpenTelemetry logs, traces, and metrics that get collected automatically. It's an easy DevOps mechanism in an opinionated way. And we can get some low config components that allow us to kind of remove all of the difficult barriers of connecting things together. The cool part about .NET Aspire is that you can use as much or as little as you want. You could even use the dashboard as a standalone container, and we'll get to see that towards the end of the demo. It's a great OpenTelemetry sync. So that project that we looked at, let's look at it in a little bit more depth. How did that start? Well, I've got this app host that is my startup project, so that's the one that launched. But I've got my front-end website. It looked a lot like a Blazor app, but it's actually just a Razor app. We've got this weather forecast, and we've got weather stations that just call into this weather API to go get stuff. Here's my weather API client that is going to go do some requests off to this API. In my program.json, I'm rigging up a link to my API service, just calling it API service, and we'll get to discover that endpoint when the time comes. I'm connecting to Redis, and here in my app settings, I don't have any details about how I connect to Redis or how I connect to my app service. All of that gets injected in based on these based on these .NET Aspire components. My backend is really similar, different than the default. I've actually rigged up the backend to cache as well. I connect to a Postgres database. We've got the Swagger details, and similarly, we don't have any details in app settings about how we do it. Yeah, we might want to override this as we deploy, so I've called it out here. But in the program itself, it just says, hey, go get me a thing. With .NET Aspire, we then get these two new projects, service defaults. Service defaults helps us fall into the pit of success because it sets up a lot of defaults: OpenTelemetry, health checks, service discovery. If we can add additional tracing providers, and I've done that here. I dig into Entity Framework and Redis that are not the defaults. And then if that variable is configured, then it will set up OpenTelemetry to export off to that OTel endpoint. But the cool part here is that with all of this content, we're given the source code. They're not hard coding this away in a magic component. And so if we have different preferences, we can definitely modify this code. And then this just gets injected into the program.cs at the top of everything and allows us to be able to get those defaults in each project. The magic of .NET Aspire is here in this program.cs where we start to rig up all of the details. So I have a password and a username secret in my app settings for this project. They just happen to be Postgres and password in this case, but they don't have to be. And so those secrets just get injected into place. I've got a database name of WeatherDB. And so I do some Postgres initialization here, saving the data to an interesting spot. And I'm specifically using the Alpine Postgres image instead of the regular one. But then I also go grab, I grab a Postgres database inside there. And then I'm just, I've got Redis together with Redis Commander. And then let's go grab the API service. Well, the API service needs to be able to link to the Postgres database and the cache. I'm also going to make it publicly available. We have our web front end that needs the cache and the API service. We'll make that publicly available as well. The View app needs a reference to the service so it knows how to get that URL. We need to inject a port number so that it knows how to do it. We could proxy that if we wanted to, but in this case, I've chosen not to. And we'll publish this as a Docker file. And so this in C# in code identifies, for the most part, a Docker Compose-like experience of starting up all of the dependencies together with all the configuration. And then automatically injecting the parameters that allows us to get from here to there. So that's pretty cool. This is a full demo that includes data storage and caching. And the cool part is this is already up online. Go to robrich.org, click on presentations. And that was number one, that demo that includes all kinds of really cool things, including, by the way, that Postgres initialization script that allows us to fill the database full of the data that we just selected. So there's that first demo. Any thoughts, any concerns, any questions about that demo so far?
I'm not seeing anything in chat yet, so we're good.
Sweet. That was pretty cool. .NET Aspire components. Now we saw a little bit of this as we auto-magically rigged up connections to Redis, connections to Postgres. These .NET Aspire components are really interesting. They bring that magic so you don't have to worry about the configuration pieces. Now on the upside, it does that auto magic thing for you, and it deploys with best practices. So for example, if I deploy this to Azure, I will get my secrets put into Azure Key Vault automatically. On the downside, they are kind of magic. And if you were to Google, for example, how do I connect to Redis from .NET, you won't get anything anywhere like this. So Googling for .NET Aspire components is kind of hard. So maybe it's easier to do it without the .NET Aspire components. Your mileage may vary. If you have a whole lot of experience doing it the regular way, then you may prefer that. If you don't have a lot of experience with .NET, that's where they really help you fall into the pit of success, no configuration with these components, and it might be perfect. So let's upgrade an existing project. Oh, actually, let's demo creating a brand new project. I'm going to close this project here, close all tabs, close solution, and let's create a brand new solution, a greenfield project. This is here in demo 2, and so I'll put it in the start folder. And let's create a new .NET Aspire project. Now, if we don't have any dependencies so far and we just kind of want to get going with .NET Aspire really fast, we can use this .NET Aspire starter app. And it has 2 microservices together with the .NET Aspire projects, those 2 service defaults in the .NET App Host project. And that gets us really cool stuff. We can also choose to add a test project. We can choose to add the caching so it will start that Redis container. And so I'll just create this and we'll see that project come to be. Now, the cool part about this project is it just has all of those components baked in, so you can start playing with .NET Aspire without a whole lot of fuss. I also love this startup page where it walks you through all the particulars. Build a new Aspire app, deploy to Azure Container Apps. The documentation here is really cool. So I've got my website. We'll see this website. It looks surprisingly familiar. It's connected to the cache. It is a Razor Pages project as opposed to a Blazor project, in spite of the fact that it looks a lot like the Blazor template. It connects off to this API service. Here's the API service that is our famous weather app. And then we have the service defaults project that lets us fall into the pit of success. ASP.NET Aspire automatically injects in the OpenTelemetry endpoint. And then we have our app host that rigs up all the pieces. Now, in this case, the front end project is the only one that is exposed as externally, which means the back end project would be inside of a VLAN and not available from the internet. That's pretty cool. And then our test, which is a really cool example of how to pull off tests inside of .NET Aspire, does basically that .NET Aspire setup pieces and then connects to the front end and validates that it can get a 200 OK. Now, I didn't say what the URL of front end was. I just said, that's the name that I happen to use here in my app host program.cs. And so I'm just going to connect to it by that name. And that service discovery is just kind of handled for me. It's a really elegant solution there. So that was a greenfield project, and it's really cool to be able to get started really fast there. But how might we do a brownfield project? If we have an existing solution and we want to add .NET Aspire to it, how might we do that? Let's take a look at this project, which, okay, yeah, I reused the API service and the web front end just because it was easy to do. But here's that web front end. And in this case, we did it the old way, the hard way. We said, go get that connection string out of my app settings file. So here in our app settings file, we'll use Redis, but I have used best practices here. I did put my secrets in user secret, so it keeps it out of source control. So I have that Redis connection. I also have that weather API URL. So the weather API URL comes in here, and now I've got that base address set. And so similarly on the back end, any configuration happens the hard way. So how might I add .NET Aspire here? Well, let's start with the back end, and I'll say add .NET Aspire Orchestrator support. And once I've chosen that, it will ask me, what version of .NET Aspire do I want? Version 9 is great. Ask me for a project name prefix and what folder I want to put it in. And I'll do that, and it will now create those 2 projects. I've got my service defaults project with great defaults. I've got my app host project that will rig up the 2 pieces, and injected into my program.cs is that reference to the service defaults. There it goes. Add service defaults. And so now I'm able to connect that way. Well, similarly, I want to rig up this one, this front end one. And so let's connect that too. Well, I'm going to say add .NET Aspire orchestrator support. And it's going to say, hey, I've already got a .NET Aspire project. Can I just use it? Why, yes. And so it will pull the .NET Aspire. Here's that line that it's going to inject, add service defaults, and I'm ready to go. Now, inside the app host, we've got references to both projects. I'm going to call it just API service and web, but we could definitely call them anything. I'll actually create a reference to it, var API service and var web. And I do that because, well, actually the web needs a connection into with reference to the API service so it knows how to get to it. We also want to add a Redis cache, so I can say var cache equals builder.add Redis. Well, that isn't a thing. It has no idea where that is right now. So let's come in here and let's add an Azure component. I'm going to say add .NET Aspire package. Oh, that is the app host. And basically it's just NuGet with some pre-filters. And so, yeah, they're just NuGet packages. They just happen to be tagged nicely. Here's that Aspire hosting Redis package. I'll install that. And once that is installed, now here in my program.cs, oh, I accept. Inside my program.cs, we'll see that we've got that add Redis resolves. I'm going to even take it a step further, and I'm going to say with image tag, I would like you to use Alpine because I know that's a really, really lightweight Redis, lightweight container. And so I'll also add the with reference to cache. Now, previously, I just said it was called cache, but I want to actually, oh, it's not a string. It's this cache object there. But in my app, I didn't call it cache. I called it Redis. So let's actually say here, I would like you to call it Redis, please. And it will inject it that way. Okay, my front-end website needs a reference to the API service. It also needs a reference to cache named Redis. And that's great. Our backend service, because we passed in that thing called Redis, we don't need to change anything else. Our front-end service is assuming that the setting for where the API URL is coming in from this app setting. Now, it actually doesn't come in this way. That isn't how the app host injects it. It injects it as this name. And so let's come back in here to our program.cs. We actually do need to modify this piece. Let's say services at API service, HTTPS 0. And as we start it up, we'll see how it gets that. And we might actually even say, well, if you don't get the HTTPS one, you could get the HTTP one. And if it exposed multiple ports, then we could go grab different ports. And so, yes, we did need to change this code, but that's it. Everything else just worked here in this .NET Aspire project. So now that I've got a reference to my cache and to my API service and web, yes, I probably need to say with external endpoints here. Now I'm ready to go. I can start it up and I don't need my .NET, not .NET, I don't need my Docker Compose file anymore because, well, that Docker Compose file was necessary to be able to start Redis. I don't need to start that in some external tool anymore. Instead, .NET Aspire is going to start my container for me. That's pretty cool. So let's fire this up. Ooh, Jeremy, you have such a brilliant question. I can't wait to be able to show you that. I'll show you that in demo 4. If I'm deploying Aspire locally hosted to an IIS server, does it show up in IIS Manager as one app or multiple apps? It shows up as multiple apps. This .NET Aspire dashboard kind of shows how those services would appear either in IIS or in Azure Container Apps or in Kubernetes. They're each different microservices, and so they would all run in separate application pools as separate apps. Of course, you could definitely configure it differently if you wanted to. Great question, Daniel. So we've got our app going. Let's fire up the front end website, and we can see that everything still works. We can come into our weather. It will cache locally for 3 seconds. If we load it again, we don't get any weather changes for 3 seconds. And then ultimately, we'll go back to our back end and get a new temperature. And apparently, -3 Celsius is scorching. So that's upgrading a legacy app. We can add the app host and the service defaults. We can also come in here and say, well, actually, I would like to measure additional things. Right now, we're not looking to Redis or to Entity Framework. We might want to add those. We could also add gRPC if we wanted. And so we could maybe add additional metric providers, additional trace providers, and it's only going to send this out to our OpenTelemetry endpoint if we've got this environment variable set. Cool. Any thoughts on upgrading existing projects or creating new projects in .NET Aspire?
It looks easy enough, and I suspect this is going to be one of those videos where people will watch this, go back, rewatch it, go back, do some steps, for themselves, go back, watch it again. So this will be highly analyzed.
Exactly why I put the source code up so that you can do it. Here's the brownfield example, and what's really cool, here's the place where we started with just those 2 folders. Here's where we ended up with the 4 folders, and so you can open them up in a diff tool. And you can go, oh, how did we get from here to there? Yeah, the video will be really helpful there too. Cool. So let's talk about deployment inside of .NET Aspire. We can deploy anywhere that we would deploy normally. Azure Container Apps is the very, very well-paved path. Kubernetes is great as well. AWS works out well. Google is coming, GCP is coming, and you could also not use .NET Aspire and use your existing deployment mechanisms if that's your corporate standard or that's your preference. When we deploy .NET Aspire, it's super easy. We can just point it at a thing and it will run. We can run it from a DevOps pipeline or from Visual Studio, and we can get our content into place. On the downside, there's some conventions, and the more that we want to take our own, do our own deployment processes, the more that we may need to replicate those conventions. And so, for example, we had to inject API service : and so, making sure that you've got all of those in place is a little bit intense. Add to that if you have, say, a Node or a Python project, you actually have to do some MS build hacks inside your app host to be able to get those projects to deploy correctly. It's a little weird. So let's talk about deploying to Azure Container Apps. This is the most well-paved path. They definitely didn't set out to only deploy here, but they deploy here as a great example of how you might choose to deploy. And so on the upside, it is really, really easy to do this. It will use Bicep under the hood. It actually spins up those Bicep templates and then applies them. And it also deploys those dependent services. So in my case, where I said I would like a Redis, it will spin up an Azure Redis cache, and it will put the connection strings inside of Azure Key Vault, and it will do all of the best practices involved in deploying. You can run a deployment to Azure Container Apps from GitHub Actions or from Visual Studio, and it'll just work. Since you can script it from a CLI, you can also deploy it from anywhere else as well. On the downside, if you're deploying to ACA with .NET Aspire, you kind of need to accept all of their opinions. One of the opinions that I'm less favorable about is it deploys the .NET Aspire dashboard. Now we'll come back to the .NET Aspire dashboard, but it's the collection of all your secrets. And so it is not exposed publicly by default, but it would be really easy to accidentally do that and expose all the secrets in your system. So next up, deploying to Kubernetes. Aspirate is a project that allows you to deploy to Kubernetes. You can either choose to deploy directly to Kubernetes, or you can scaffold out the features that you want to deploy to Kubernetes. And it works out really great. On the downside, the Kubernetes YAML is only the deployments and the services. It doesn't create the ingress. It doesn't create config maps and secrets. It doesn't create dependent resources. It's only just those deployments and services inside of Kubernetes. But it is a great way to be able to get those services started. And so another way to deploy to Kubernetes is, well, craft your YAML. Either use Aspirate to start them, or just if you're good with Kubernetes YAML, you can just build the Kubernetes YAML as you need it. Now, you do need to keep track of the dependencies and make sure they're available. You need to follow the convention to set the connection strings just so. And so you don't have the auto magic of .NET Aspire here, but you can get it into Kubernetes in exactly the way you want. If you have existing resources in Kubernetes, maybe this is perfect. Deploying the .NET Aspire dashboard. Now, in all of those auto magic mechanisms, it does deploy the .NET Aspire dashboard. And you can't easily opt out of that. It will deploy too. The .NET Aspire dashboard is great for local debugging, but it doesn't have any durable storage. Now, there is a plugin to be able to power that. It kind of pushes that off to a third-party service. But because it doesn't have any durable storage, it's not great for understanding what broke yesterday. And it's easy to accidentally make this public, in which case you're exposing all your secrets. We saw that we could see all of the configuration values for the entire solution. And so it would be really easy to accidentally lose content because you exposed the .NET Aspire dashboard. So in my opinion, don't deploy the .NET Aspire dashboard. Instead, in production, rig up OpenTelemetry using standard mechanisms. Use Prometheus and Jaeger, or use Azure Apps Insights or New Relic or Splunk. Push these logs to a more durable place that it already exists in your organization for this content. OpenTelemetry is a great standard that has kind of taken the world by storm. And so I bet you have OpenTelemetry syncs in your organization already. So let's take a look at how we might use the .NET Aspire dashboard outside of .NET. Here's the fourth demo, and this one is really cool. I'm going to use Visual Studio very briefly for this, but the majority of it actually happens outside of Visual Studio. So here's number 4, standalone thing. I'm going to start with this Docker Compose file right here, and this Docker Compose file will start up all of my services. We'll start the Aspire dashboard container. We'll forward out some ports. Now, it does start the gRPC collector on a non-standard port and the HTTP collector on a non-standard port. We could choose to override those, but we can just use Docker Compose to shim them into place. We'll set some environment variables, like what port do we want to start the .NET Aspire dashboard on, and we want to allow cores. We'll also disable the authentication that we've been using into the .NET Aspire dashboard. We'll also start up Postgres and the Postgres admin tool. We'll also start up Redis and the Redis admin tool. And so all of these will be here ready to go. Let's do that. We're in that correct directory. And let's start up Docker Compose up. And so we'll start up all of those pieces. We've got now the .NET Aspire dashboard. We've got Postgres and Redis, both of their admin tools. So we can come back over here and we can say, I would like to go to the .NET Aspire dashboard, please. Localhost 8000 gets us exactly there. Oh, did I guess the port wrong? Or did I rush the container? I rushed the container. There we go. Now, as we see this .NET Aspire dashboard, we can see we have structured logs, traces, metrics, but we don't have that service discovery piece. There is no app host that says, here's all the services in my solution. It makes a great OpenTelemetry sync for local debugging. We just point various apps at it, but it doesn't know where those apps are. That's okay. So now let's go start looking at some of the apps. Well, here I have a API service. We've seen this API service before where we just go do a query into a database. We also have a hard-coded thing. And so let's spin that up. But instead of the front end, I'm going to start up a load test. So here I've got a program.cs that will connect off to that API service. And then I've got a worker that every 2 seconds will go get the forecasts and get the stations just so that we can see that that is running and we'll get really elegant logs in our OpenTelemetry dashboard. So let's fire up that solution and take a look at that data pumping into OpenTelemetry. Here's that solution. And now in this case, I do need to go back into the old way of saying configure startup projects and get it to start both projects. The cool part is inside of OpenTelemetry, we didn't have, or inside .NET Aspire, we didn't have to do that. It knew where all the projects were and it just did it. So we've got multiple startup projects enabled and we're gonna kick that off and we'll get both our backend and our service tester. So here's our front end website and here's our service tester. And the service tester will kick off every 2 seconds to do the thing. Here's our UI for that app. And what we can see now in the structured logs, we're getting all the logs for our apps. We're getting traces. I love this. Here's our console app going to do the test. In this case, it got a cache miss. So it generated it and then it cached it. Here it's doing a query into the database. And so we've got that Postgres connection right there. And it's going to continue to spin, but let's look at the other projects that we have in the solution as well. We have our View app, and the View app is really similar to that .NET front end. And so let's start up that View app. Now, as part of the View app, I do have it inject in the API URL. And so I'll just look for server URL right there. And so let's come here and inject that server URL into place. I will say env server URL equals localhost. And where is my backend? My backend is (7364). Cool. So now that we've got that server URL in place, let's run View and we'll see that we've got our View app. It's going to start up here on localhost 3000. Let's come here to localhost 3000 and we've got our weather forecasts. We can refresh them. Did I type in the wrong URL for that backend API? Let me look at the launch settings real fast. 7364. Oh, I did send in the wrong URL because I sent in HTTP. Let's do that again. It is not HTTP, it is HTTPS. Let's fire it up again. There we go. Back here in View, we can refresh our forecast, and the server is still caching for 5 seconds. But because we rigged up OpenTelemetry here inside of our View app, nope, right here, then it's going to send that data off into .NET Aspire. So let's come back to our .NET Aspire dashboard here, and we'll see not only the console tests, but we'll also see our View app. Hey, that's pretty cool. The View app did a quest off to the backend API. In this case, we got a cache hit. It only hit it twice, and away we went. So if we focus on our View app here, we can see that here's a cache hit, here's a cache miss, and now we have hitting Redis and then generating it and saving it to Redis again. Now, in addition to the View app, I also have here a Python app. Now, this Python fast API, I've just made it do, weather forecasts. If you squint real hard, you can see the backend API here. And so let's start up this Python app. Now, I've already set my virtual environment into Python here. And so I want to cat start, let me look at the files here, cat start.sh, and start.sh will just OpenTelemetry instrument my Uvicorn app and set all of the parameters that I need, like the endpoint that I've chosen for my .NET Aspire dashboard. Cat start.ps1, and it's exactly the same, except for I'm using PowerShell. So let's start .ps1. We'll start our Python app, and it will be on port 8001. And now if I come here to this, I can say localhost 8001, and I will get my Python app. Now, the cool part about this Python app is it returns the exact same interface as our .NET app here. And so if I were to say, I don't know, swap out my View app to, instead of calling .NET, to calling Python instead, then we could get the exact same experience. Now, right now, this is caching on the server in .NET, but let's switch this project over here to instead call the Python app. So HTTP localhost 8001. And now if I npm run dev, now Node is not pointing at .NET, Node is pointing at Python. So let's do some more requests inside of Node. We see that it's not cached anymore. And if we come back to Aspire, we can see that those traces here in the View app are now going to Python instead. That's pretty cool. Now, in this case, Python and View are not logging into the structured logs. Only .NET is doing that right now. But we've got traces, and that is a really elegant way to be able to look through all the pieces. So in this case, we ran all of these pieces locally. We've got them all pointed at this container inside of Docker Compose. But what if we instead, let me stop the View app here. Let me stop the Python app. I'm actually just going to close the tab because the Python app, oh, let's also stop the .NET app here. Stop. Yes, I would like to stop debugging, please. The Python OpenTelemetry piece will actually, there it is, return really fast. And so just closing the terminal or just closing the process may not be enough to kill off the Python app. Okay, so the other piece that I have in each of these projects is a Docker file. Here's the Docker file for the Python app. I've got a Docker file for the View app that, by the way, hooks up OpenTelemetry inside of this Nginx container. We've got a Docker file for both the front end and the back end. And so let's take a look then at this Docker Compose file. that will start up all of my apps. So we're going to start up our API service, injecting all of the things that .NET Aspire would have, including the OpenTelemetry endpoint. We're going to start up the load test. We'll start up the view app. In this case, we're going to point the view app at the Aspire. And we also have a hard-coded API service URL to .NET because, well, I had to pick something because that actually gets built inside the Docker build here. It's not a runtime configurable property. Okay, so we've got the Vue app. We've also got the Python app, and all of those can be ready to go. Let's now say Docker compose -f up, and we will start each of these as containers. Now I have built the containers previously, so I guess I'm a little bit cheating the demo there, but all of the source code for those containers is already up here on GitHub, where we have the API, .NET API, the .NET load test, Postgres, Python, the Vue app. So now that we've got all of those in place, let's start playing with them. So I want to take a look at the .NET app. It's running on port 8080. There's .NET replying. I also want to take a look at the Vue app. It's doing the Vue app things, and it's pointing at .NET because I'm caching here. We can take a look at the Python app and get some random weather data there. We can also take a look at the Postgres admin tool and take a look at connecting to Postgres. We could also connect to Redis, the Redis admin tool, and all of these then flow back into .NET Aspire, where we can see, well, our console is doing really cool things. Here's the Python app logging its details. Here's the console load test. Here's a cache hit where it didn't need to look it up, but we can see we've got a connection to Postgres in our weather stations one, and API service is caching that data there. We can also take a look at the Vue app. So I'm just going to filter here by the Vue app. And the interesting thing here with the Vue app is that the Vue app connects to the Nginx backend that proxies through to the .NET backend that is actually querying into Redis. And so we can see all of that go through all of the pieces. We have excellent tracing through our app, and we're able to see the length of each of those requests and pull up the details of each of those as well. And so the cool part about this, that's .NET Aspire running as a completely independent piece. This has nothing to do with .NET per se. It's just a really cool OpenTelemetry sync. Any questions or thoughts or concerns about running .NET Aspire outside of a .NET project?
No, not that I see, and I think you have proven it quite well.
Sweet. Can Rob show what an exception looks like in the .NET Aspire dashboard? I'm curious how to troubleshoot other than HTTP. That sounds really cool. Let's do that in a minute. But before we do that, let's kind of finish up thoughts here. So the standalone dashboard is really cool. Standalone dashboard allows us to be able to use this just as a generic OpenTelemetry sync. Any apps that we want to pipe OpenTelemetry data into, we can do that in a really elegant way. So here's some of my opinions about .NET Aspire, and they're definitely mine. Where does .NET Aspire make sense? Well, it depends. And the cool part about .NET Aspire is you can use as much or as little as you want. If you're using OpenTelemetry today, then .NET Aspire definitely makes sense when you're debugging locally because you've got the same kind of telemetry that you have in your production apps. If you want to start all of your microservices with one button, then .NET Aspire works really, really well. If you've already solved service discovery and deployment, then maybe .NET Aspire's opinions don't help, and you might not want to use this. But again, you can use as much or as little of .NET Aspire as you want to. So maybe you're using the debugging pieces, but you're not using the deployment pieces. Or maybe you're using the deployment pieces because you like not having to figure out bicep, and maybe you're not using the development pieces. You can just definitely use as much or as little as you want. On the downside, .NET Aspire really does like containers. And so if you're doing a whole lot of things, it tends to use a container runtime. You can use either Podman or Docker Desktop. But if you don't want to use containers, then you can just avoid those containers inside of your app host. Here inside of my app host, I chose to start a Postgres container and a Redis container. I could also, for example, just run those from the command line instead. Azurite is a great project that allows you to simulate Azure or to emulate Azure storage. And you can just launch that from the command line, or you can launch it from a container. And so for one of my projects, we just happened to start it as a command line here. So .NET Aspire. .NET Aspire is a really, really good way to bring a whole lot of industry standard pieces together in one spot so that we can build really great web services, really great microservices, start them all together and use really elegant defaults. Now, unfortunately, it's called .NET Aspire because it kind of implies that you can only use it in .NET, but we saw how we could use it in Node and in Redis and in Postgres and in Python. It has nothing to do with .NET. Yes, it's really well paved in .NET, but you can use any OpenTelemetry projects inside of .NET Aspire. .NET Aspire is great at running containers, .NET projects, command lines, and that opens up the possibility for anything. This has been a lot of fun getting to show you .NET Aspire. Let's dig into that question of throwing an exception in a minute. But the cool part is that all of the source code for all of the demos, both the start and the done, is available up on GitHub right now. If you're watching this later, you can head over to robrich.org, click on presentations, and you can get straight to the code up there on GitHub or to the slides and start to do that. If you are watching this in the future, I would love to connect with you. Hit me up on all the socials. But for those here in the group, what questions would you like to dig into? Let's dig into the exceptions ones too.
So a question that came up just a minute ago was how do the view click dashboard entries work in OpenTelemetry? Is there an OpenTelemetry library for view that needs to be configured?
Ooh, good call. OpenTelemetry. There's OpenTelemetry SDKs for most languages. As soon as I say that, we're going to find some language that is really exotic that isn't that. But you can see Swift, Rust, Ruby, Python, PHP, Java, JavaScript, Go, Erlang, .NET, C++. There's .NET. In the browser, it's a little bit different because you kind of have to do some other interesting things. By default, OpenTelemetry is going to try to use gRPC, and we need to use HTTP because browsers can't make gRPC calls. But we go install these libraries and then initialize in this case, TypeScript. And then we could choose to do that. But then here is that magic sauce. So I'm going to come into GitHub and let's take a look at our View app. Inside of our View app, I have basically the copy and pasted version of this file right here. And that's here in tracing.ts, where I just pass in an object that includes all the parameters that I need. It fires up the configuration that starts OpenTelemetry. It's going to use the OpenTelemetry HTTP URL, which requires the /v1/traces at the end. And then it, in this case, does a console log exporter, as well as the OT OLTP exporter. And then get web auto instrumentations is great because it grabs document load, fetch, user interaction, and XML HTTP request. And so I don't need to include all of those little libraries to get each one. So I drop this file into my project. I then, in my main.ts, I go grab those environment variables and call it, and that rigs up my OpenTelemetry inside of a Vue app. I use this exact same tracing.ts in a React app, and it works just fine there too. That was a great question. Yeah, in the browser app is a little bit weird. They're really good at calling out the differences between browsers, though. Browser and Node.
All right. If you have any other questions, you're more than welcome to ask them here. You can come off mute and ask if you would like. Okay. In case this wasn't mentioned, I was wondering what would be the most elegant way to do service discovery. For instance, in my UA Blazor app, I call my API, and the base URL is stored in app settings, and I retrieve by using configuration. Get this thing out of the way. How would I construct the base URL instantiation based on if it's in the Spire, and then use localhost versus if it's published on a server, and then take the value from the appropriate app settings based on the ASP.NET Core environment variable.
Ooh. We did that a little bit here in demo number 3 when we talked about Brownfield, because here in our web app, our front-end app, we go look for that configuration. Now it comes in as services, API service, HTTPS 0, but you could really easily say, let me go check that and see if it's set. And if not, let me fall back to the old way and go grab the app setting that way. That might be a really great way to be able to say, let me go look here and there. App settings, API service URL is what we had previously. So let's talk about exceptions, because that was a really fun thing. I'm going to throw an exception here in my API. So instead of getting weather data, I'm going to say throw new exception broke. Now probably I'm going to get the yellow screen of darn, and so we'll see. I also might get a build fail because I have unreferenced code, but let's give it a try and see what an exception looks like in .NET Aspire. I worked really hard to make sure this didn't throw exceptions, so I'm really curious too. Yep, unreachable code detected. I love to turn on warning as errors so that my build will fail if I have any questionable code. So I'm surprised that it didn't blow up there. I'm failing to get the anti-forgery token because I'm not persisting the keys into Redis. That would be an easy move to make, though. And up pops my app. Let's go to the web front end. And let's ask for the weather stations. That's the one that's going to explode. And I get that explosion inside of Visual Studio. I would like to continue, please. Oh, it's not going to let me through. It's continuing to retry it. That's awesome. Um, Here in the console logs, I'm confident that we'll see. Oh, because it's paused. I'm confident that we'll see the error right there. Yep, there it is. And so in the structured logs, we would see that as well, which is really cool. Ooh, that's really juicy. That's cool. And so I guess the magic question is, can we see a stack trace? And I don't know the answer to that question. Let's explore together. Oh, yeah, there's the stack trace. Nice. Oh, that was really cool. I've
Okay,
got
so
a new toy now. Thanks for
that
that
is really
question.
cool that the Aspire dashboard has a text visualizer.
Yeah.
That's nice. Oh, okay. So what are the options when you say up there in the upper right for select format? Okay, unformatted
Ooh,
JSON,
it looks like it
XML if
would
needed.
detect things.
Yeah, I
Yeah.
like that.
I like the copy to clipboard button too. Well, this was a lot of fun getting to show you .NET Aspire. Thanks everyone for coming. It was a really cool time. If you're watching this in the future, head over to robrich.org and you can grab the code and slides. They are available online right now.
Rob, thank you so much. I really greatly appreciate this. This was a fantastic presentation. The demos were awesome, and there's a lot of great comments in chat about this, and it's really neat to see what it can do and the connection, because we've seen the Aspire demos before, but seeing the integration demos with like OpenTelemetry and things like that, this is really cool. So this is needed.